Functions, what are they? If you are going to walk from one place to another, that takes time. The relationship between time and you walking with the distance is referring to a one-way function. So how much time will you take to walk a certain kilometer? So if the distance changes, time also change. So that is a one-way function. That's what function means. As an introduction, functions has names. Okay, so in math, we name functions, and the notation is same as your time and the path that you walk, okay, the distance that you are walking is same as x and y in function. Alright, so let's start with the names of functions. So functions has names. So what are the names of functions? You can have f function, so you can write fx, g function, gx, hx. These are the most common ones. You can have any letter. So we call these as the names of function. Right? Why do we need the f, the g, and the h? See, functions can be inverse. It can also be composite. So when you say composite, that means you are going to combine the f function with the g. So it becomes fgx, which we will discuss later on. So these are the names of functions. Types of function. What are the types of functions? By the way, functions, if you are going to graph them, if you are familiar with the y equals mx plus b form, this is another way of writing a function. So this is another way of writing a function. But the proper way is you start with the name of the function. Alright? So this is also another way of writing. That means when you are going to graph the functions, you are going to write it this way. So you are going to find the value of the y. Okay? What I said earlier is the distance of walking and the time. It's similar to your x and the y here. So the y here is the output. The x is the input. Okay? So if the x changes, so the value of the x moves up, the value of the y can move up. If the value of the x moves down or decreases, the value of the y also decreases. That means if the distance that you are walking increases, the time, which is the y, also increases. I think that's clear, right? So that's how we view function. If you are going to graph again function, these seem to follow certain line. Okay, some functions are curves. The most common one is a straight line function. That's what you've learned from your basic math 1. So this basic math 2. Okay, so let's write a few examples of types of functions. What are types of functions. So you have one would be straight line. So you have a straight line function. So you can write as example would be fx equals 2x plus 1. Right? So take note of the x here. The x has only 1 raised to the power 1 there. Okay? So another function would be quadratic, the one we do find the x before. So quadratic has maybe fx equals 2x squared plus 1. Okay, so let's graph this two. If you are going to graph a straight line function, what you are going to have is somewhat like this, straight line. But when you graph a quadratic function, you have learned from the previous videos, it was like that. That means you have two x's. Okay, so you have your x1 and x2. I know what you're thinking. So the next one that would follow would be x raised to the power 3, right? So we call that as cubic function. So cubic, you're going to have, let's say, gx equals 2x squared, cube, plus 1. Okay, so for this case, the graph would be like that. Or maybe it's steeper, but the line would pass on the x-axis 3 times. Okay? More functions are exponential. That means instead of the squared here, it would be the x. Okay? And opposite to that is the logarithmic function. If you are going to have the exponential function be graphed and below would be the logarithmic function, then you will have a certain midline we call as asymptote. Alright, so another type of function would be radical function, rational function. They have different lines, but most of those lines are curves. Okay? And then you have the sine or the trigonometric functions and so on, right? So this is function. Okay, so let's find the values in the function. Alright, so I have here example number 1, gx equals x squared plus 1 divided by 2. Find the value of g, close and open parenthesis 10. What does it mean is that it means that we are going to substitute the x with 10. Okay? So that we are going to have g10 equals x squared plus 1 over 2. So this is how we usually write. So this is denotation. So this means what is the value of the function g if the x is equal to 10. Alright? So you are going to have gx 10 squared plus 1 divided by 2. Alright, so you then have 101 divided by 2. Then you will have gx here. So remember our y. So without the name, the g, you will have y equals 101 divided by 2. So you will have gx equals 50.5. You can see it. So this is 50.5 here. Okay, so I said earlier, what if the value of the x changes or decreases? Will it decrease the output also? Yes, of course. So right here on letter B we have gx equals negative 2 squared plus 1 divided by 2. So that means you have negative 2 times a negative 2, so both negative will produce a positive answer, right? So that means 5 divided by 2. So the answer would be gx equals 2.5. There you go, example number 1. The function is written as f colon x arrow 2x plus 5. This means that the function f has an x that will produce. Okay, so if you are going to view the arrow, just similar to the equals or the equal sign, but for this case we use the arrow because we intend to say that the f function has or will produce 2x plus 5. If you are going to remember chemistry, we also use the arrow to note that the reaction of two chemical substance will produce this kind of substance, somewhat like that. Alright? So don't worry about that. This is another way of writing a function. So in the question it says, this function, and if f close and open parenthesis a, which means this function, is equal to 20, what is the value of a? So you need to find a. This means that this side right here is equal to 20, f a. Alright? So we did not write 20 inside because we mean that the whole left hand side of the equation is equal to 20. That's what it means. So what we are going to do is we are going to have FA, which is equal to 20, equal to 2x plus 5. Alright, so that side of the equation. So you can write here all of it again. So all of this is equal to 20. So you have 20, 2x plus 5. So what to do with this? I know what you are thinking. So we will do the first degree equations, or we will transpose the values of this side to the side to find the value of the x. Okay? So this means finding the value of the x that makes 20 all in all. So you find already the y here. But your problem is, what is the value of the x? Alright? Later on, we will talk about that. The domain and the range. So in this case, you have the range being found. And the x, the domain, is not found. Okay? And if you recall, in your graph, you have your t-table as x and y, right? So for this case, you found already the y. I mean, yes, you found already the y. So you found this side. You did not find the x. Okay, so you have values here, right? So you did not find the x, but you have the value of the y. Okay, so we transfer now, or transpose 5. You are going to have 20 minus 5, then 2x. So you have 15 equals 2x. Then you have to divide it with 2. Divide it with 2. The x would be equal to, okay, so the x will be equal to 7.5. Alright, so this means the value of a is equal to 7.5. So you can write this as a is equal to 7.5. Am I clear? So how to check if our answer is correct? So we substitute that there, and then we should find 20. So 7.5 times 2, that means 15. And then you add with 5, you will get 20. Easy, right? Example number 3, guys. Alright, so in this example, you have two functions. And we are asked to solve the equation of the two functions on both sides of the equation. And as you can see here, key has a value of 3, so that means we are going to substitute this 3 that x there. Okay, so what I mean is that we will write this function here, which is 1, 2 over x plus 1. So 12 divided by x plus 1 equal to, here you have 2 raised to the power x minus 1. But then remember that it is written key close and open parenthesis 3. So this means the 3 will go right over there, right? Oh, it should go right over there. So then we will have 12x plus 1, and then you have 2 raised to the power 3 minus 1. Then that would be, this one would be equal to, okay, so for this case, 2 times 2 times 2, that means 8. Minus 1. And then right here, 12x plus 1. Right, going further, you are going to have 12x plus 1 equals 7. Okay, then you transfer this 1 to the other side of the equation. That means 7 minus 1, 12 over x. Then what is left is 6 here, and then you will have 12 over x. Alright? So in the process, you are going to multiply this with 1 over 12. Okay? So either way, it's fine. Alright, you will have the same answer. Okay, so multiplying 1 over 12 on both sides. So times 1 over 12. So crush out, right? And then this side also here, have 1 times the x. Alright? So then your answer would be x equals 6 over 12, which then can become 1 over 2, or 1/2. Easy, right?